All right, let's go ahead and take care of section 1.5. Remember, this section we've decided is going to be optional, although anytime we're talking about having story problems, then it's optional, but it's never going to go away. So it's going to come back. I want to point out that this section is really talking about the plan and the idea of that you need to read and understand a problem, you have to decide on an approach and pick a formula. There are some formulas that are more familiar than others, right? So formula, solve the problem, and look back. So I want to point out to you right here that there are some common formulas on page 30. These are the ones that usually we expect you to have in your head. So some examples of those, not all of them, but just some examples are right here on the left-hand side. C equals 5/9 times F minus 32. In this formula, we're going to input the number of degrees we have in Fahrenheit, and our output is going to be degrees Celsius. So input and output. In the second example, I equals PRT. We usually see this one written just a little bit differently. We usually see it I equals PRT without the little dots. We know that that means the same thing, but I'm not sure that you've seen this one as often as I think you've seen it, so let's just talk about it for a quick second. In this problem, the input values are going to be principal, rate, and time. So P, R, and T. That word principal, remember, means money invested. Rate is always used in decimal form. And in this formula, time is always expressed in years. And once we plug those values in, the output is going to be the interest that we earn. This third one I know you've used in science class. Again, I'm not real crazy about the format here. Remember, usually when we see this formula, it's not a capital D, it's actually usually a lowercase d. Distance equals rate times time, dirt, right? DRT. Input is your rate. That's going to be a unit rate, just like we saw earlier, like miles per hour, inches per second. And when you measure that time, that measurement needs to match whatever's in your unit rate. So that this unit rate is kind of the determinant of what your time is in. So if they give us miles per hour and the time they've given me is at 30 minutes, we need to use 1/2, right? 5 miles per hour. And if they gave me 30 minutes, I'd have to use a time of 1/2 to make sure that I match. Hours in my unit rate, hours in my time. Remember that output is going to be distance. And again, it's going to match your unit rate. So that if I have miles in my unit rate, then my distance coming out is also going to be miles. I know you know that, but I wanted to make sure we talked about it because it's an expectation that you already know it. All right, let's go to this fourth one over here. This fourth one is kind of funny looking, this pi. Looks kind of like pi. It's one that's inherent in things that you already know. But it's not one we really see as expressed as a formula so much as something we're supposed to just understand about the world. This formula is talking about the fact that I have input values that are called income and expenses, and my output value is profit. So the big catch is making sure that you understand that there's a huge difference between what money comes into a business and the fact that the profit is the money that they make. So money coming in doesn't necessarily mean profit. So be careful. We have to subtract out those expenses before we actually have profit. So just be cautious with that one. There are a bunch of examples here that I'm going to go ahead. I'm not really going to talk through a ton of them. I might do a quick little thing filling them in because we did make it optional. I don't want this to be a long video. So let's scroll down here to example 1. You make 35 dog collars and anticipate selling all of them at a craft show. You spend $85 on materials and hope to make a profit of $90. How much should you charge for each collar? What do we know? We know the number of collars we made, number of collars made. We know our expenses. And we also know our profit. Number of collars made, our expenses, and our profit. So what we really need to know, what do we need to know? How much to charge per collar, right? What do we need to know? How much to charge per collar? What could we use to solve the problem? Well, it makes sense to me to use that last formula. Profit equals income minus expenses, knowing that our answer is going to be involved with this income part, right? We have expenses, we have profit, so our missing value is going to be in part of that income value. Now we can go ahead and solve it, although oftentimes in this section we aren't asked to solve, which is why we're going to skip it. It's really knowing how to answer these three questions that we're really looking for. But let's fill in some values so we have just a little extra work. We want to make $90. Our income is going to be the 35 collars we sold, right? Or, I'm sorry, the 35 collars we made times how much we're going to sell them for. So $35 times whatever we're going to charge is going to be our income. And once we have our income, then we have to subtract out how much we spent to make those collars. We spent $85 in this case. So then we have all of our solving skills, but those come in chapter 2, really, and since I don't want you to solve this one by mental math, this is enough information for section 1.5. Now you see why we can skip some of it. Stuff you already know. This one on example 2. I want you to go ahead and give it a try. So stop the video, fill in what do we know, what do we need to know, what could we use to solve the problem. Go ahead and pause it now. Hopefully you did in fact pause it, because now the answers are up on your screen. And what do we know? We know 1 Celsius and 1 Fahrenheit temperature. We need to know which temperature was higher. And we're going to use the formula C equals 5/9 times the quantity F minus 32, or degrees Fahrenheit minus 32. Remember that this side of the problem is your input side. So we're really going to change that Dallas temperature into Celsius before we compare. Section 1.5 does not ask you to do it, just to identify what formula you would use if you were asked to do so. Same thing, give example 3 a try. This time we are going to be asked to solve. So what do we know? What do we need to know? What could we use to solve the problem? And then actually solve it this time. Pause it and do it. So hopefully you paused it and you wrote it out. This was an I equals PRT problem. They gave us the principal, the amount we invested, the time of 2 years, and the rate 5%. They asked us to find the amount of interest we could earn. Here's our formula, I equals PRT. I just wanted to make sure I pointed out to you that 5%, right? Move that decimal over 2 places to get 0.05. Or if you don't like decimals, you could just as easily have used 5 over 100, and this problem might have been even easier. You can see my math. I showed you what I thought in my head. I put it over here on this side for you. So that we end up with an I equals 120, which means in this problem, my interest is $120. $120. Don't forget that units are important, right? We always write money all the way out, but we don't have to put the zeros. All right, I think there is one more problem here for us to look at. So if you want to pause it and look at example 4, yep, one more. And just in case, let's see, what are they asking us to do? How much more dough? Dough, surface area. There's your big hint before you pause. We're talking about area in this problem. Go ahead and pause it. Give it a try. Alright, hopefully you worked through this one, and your answer might not be as complete as mine is, although we should still end up at the same answer. And there's one spot where you might have done your work a little bit differently. But notice that there are two big pieces here. It takes 0.15 or 15/100ths of an ounce of dough per square inch of the pan. So we need to find out how many square inches in each pan, then multiply by 0.15 in order to find out how much dough. And then how much more, that's a pretty key word there, that word more. So we need to make sure we do a subtraction at the end. So what do we need to know? We want to know how much more dough each pan requires. No, I'm sorry. We need to know how much dough each pan requires to make a thick crust pizza. What can we use? Well, we'll need to use the formula for area of a rectangle. It's not in the list here in your notes. Then we'll need to multiply the number of square inches by 0.15 to know how much dough each pan will need. Then we can subtract to find out how much more dough the larger pan will need. We can actually reverse this multiplication and subtraction step. It doesn't matter which order you do them in, you'll get the same answer. But that's the order I happen to do the problem in. So when we look at this, remember that area of a rectangle is inside your head, length times width, or base times height, depending on which way you like to use it. And when we do our multiplication, we get the area of the first and the area of the second pan. Remember, to find the amount of dough, we take the area of the pan times 0.15 ounces per inches squared. So we're going to have how many square inches. This will be, the area of the pan will be square inches, so that those two will eliminate or simplify, leaving us with just ounces. We do those two multiplications, and finally we finish with that subtraction step, finding how much more. So we end up with 10.35 ounces. So again, section 1.5 is kind of an optional one, but it's a good place to start talking about story problems, because that's where we'll start focusing our time in the next couple of days. See you in class.